Okay, in this tutorial we're going to talk about trigonometric ratios. And it's a really useful thing to be able to work with to work out the angles and sides in a right angled triangle. So I think the simplest way to explain this is just to delve into an example, and I'll explain as I go, and I'll go into a bit more detail after the example, once you've got a rough idea and feel for what they are and what they can do. So we'll start off just by drawing out a right angled triangle. Okay, and we'll put the right angle in as well. Now, say in this right angle triangle you're given two side lengths. Say hypotenuse is always the longest, so say 10 and 8, just for simplicity. And say you're asked to find the angle theta over here. The first step before you think about anything, as long as you know that it's a trigonometric problem, and you can solve it through trigonometric ratios, is to label the sides. Now the side opposite the right angle is always the hypotenuse, so we can label that straight off. Now, the other two sides are labelled according to either the unknown angle, in this case theta, or a known angle apart from the right angle in which we can work with. So say this angle up here is known, the other two sides will be labelled according to that angle. But in this case, this angle here, theta, is known, so we label the other two sides according to angle theta. Now, the side opposite the angle is imaginatively called the opposite side, so we label it OPP, opposite. The side next to the unknown angle or the known angle apart from the right angle is called the adjacent side. Now, there's two sides adjacent to theta, but one of them is hypotenuse. That's always the hypotenuse, so the adjacent side is the other side. And so now we've got that labelled, we can think about what information we've got in relation to the trigonometric ratios. And there's a simple little rhyme to remember the trigonometric ratios, and it goes like this. Silly old Harry caught a herring trawling off America. Now what does this mean? What does this mean? The first letter of each of the phrases, three word phrases, S, C and T, represent the sine, cosine and tangent. And they represent what trigonometric function you're going to be working with, either the sine, cosine or tangent. The other two represent two sides, and that's why we need to label them. So if I write them out in full, you'll get a better appreciation for what they mean. So here, the sine. So the sine equals the opposite over the hypotenuse. Here, the cosine, or cos, is equal to the adjacent over the hypotenuse. And here we've got the tangent, or tan, is equal to the opposite over the adjacent. So if we think about this example here, the problem we've got, the two pieces of information that we know are the hypotenuse and the adjacent. So we'll start off with the sine. Well, we don't know the opposite, so we move on to the next one. We know the adjacent, yes, that's 8. We know the hypotenuse, yes, that's 10. So now we can substitute into so now we know it's a cosine, we can substitute the values we know in. So the cosine or cos of angle theta is equal to adjacent over hypotenuse. So the adjacent here is 8 over the hypotenuse, which is 10. Now, as long as the fraction is in its simplest form, it's best to leave it as a fraction, because quite often you'll get really long decimals or recurring decimals, and then you can bring in random approximations. It's better to leave it as a fraction. But now we've got two values on the left hand side, so we want to move the cos is a known value, so we need to move it to the right hand side. And to do that, we always, whenever you move either cosine, sine or tangent to one side of the equals to the other, we change it from, say, here cos to cos to -1. So here it would be cos to -1, open bracket, 8 over 10, close bracket. Now, to do trigonometric ratios, you're going to need a scientific calculator. Quite often, the cos negative 1 or tan negative 1 or sin negative 1 is a second function button, so either you press shift and then the button of their respective trigonometric function. So for example, cos negative 1 is a secondary function of the cos button. So if I was typing this into my calculator now, what I type is shift cos, then I get up cos negative 1, and it automatically brings up an open bracket, so you don't need to put an open bracket in. And then you could just put in 8 over 10, and don't forget to close the bracket, and then you'll get 36.86989 and so on. But we'll round this down to 2 decimal places. So theta equals 36.9 degrees. I'll go into more detail in trigonometric ratios in another tutorial, including how to work out the side lengths, a side length if you've got, say, one side and you know an angle. I hope you've enjoyed this tutorial and found it useful. Don't forget to like, subscribe and comment. Thanks for watching.